All right, hopefully folks online can hear us. Cool. So welcome everybody. Again, great crowd, and welcome to the Cleveland Big Data Meetup. If this is not your scheduled destination, you're welcome to stay. It's all good. Just you'll stay and you'll learn something about large AI and LLMs and GIS. And again, huge thanks to CSU for hosting us. With this meetup could not happen without three things. Great location, a pizza sponsor, and great content. So first, I want to thank Cleveland State for hosting it. So thank you. And right on cue, right on cue. Thank you, Sonny. So we've got three talks. Ian Maurer with improving LLM reliability through tool usage. Rob Hryniewicz from Cloudera with Gen AI for Enterprise, and then Sohrabian, Mapping Eternity, the city's new geospatial cemetery management system. So I've got a few announcements here, and then we're going to get on. So one, a friend of the show. I always have to remind people of this. If you do a talk for the meetup, you become a friend of the show, and that's that's an honorific for life. You can put that on your resume, you can put that on a business card. You cannot gift it or will it to, say, your children or spouse. It's more like a life peerage, but it is yours to keep. So if you would like to become a friend of the show, just please let me know. I'm always looking for new speakers. If you know anyone that has an interesting thing to talk about, please hit me up. So again, that can be yours for life. Next one, the next meetup is going to be in March at Baldwin Wallace. So there'll be more information on that. And then another one, I've been doing some of my nerd hobby writing. The latest one for the ACM was When Data Worlds Collide, Critical Sections and Analytic Workflows. It sounds like a Jerry Bruckheimer movie. I'm kind of angling for that. But yeah, it's some real life lessons learned back from Explorus in data onboarding for again, for analytic workflows. So a few announcements. Cleveland AI Meetup is meeting in a couple of weeks, February 7th. Actually, no, it's next week. Yeah. Next week, February 7th, 2024. So talk to these guys right here, Ted and Will. And also Hack KSU from Kent State University is reforming. They wanted me to do an announcement. Regional announcements. So for anyone that's interested in either speaking or sponsoring or getting involved with that student group, please reach out to them, Hack KSU. And are there any recruiting shout outs? I didn't get any in advance. If there's anybody that's hiring, anything to announce, anything at all? Going once, going twice? No recruiting shout outs. Cool. So with that, oh, I almost forgot. Thanks to Esri for the pizza sponsorship. And again, of the three things that we need for a great meetup, one location. Thank you, CSU. Esri paid for the pizza tonight, so everybody give Esri a big round of applause. And thanks to you for the Linux Foundation. The Linux Foundation is letting us use their Zoom, and also they've been posting the recorded content to the Linux Foundation YouTube channel. And as always, thank you to Cleveland Big Data members. This meetup could not exist without everybody here, and it's a great crowd. So with that, let's get Ian up for the first talk. And I have my
okay. Yeah. Ready to start that. Hit the timer. I get 6 extra bonus seconds.
Exactly.
Not hearing anything. Stop share. Everybody hear me okay? Ooh, sorry. And I'm going to press the button. Oh no. Start. No, it's not going anywhere. There it is. Hello, I'm Ian. I'm the CTO of Genome Oncology. We're a precision oncology provider in Lakewood. We've been around Lakewood, Cleveland. I live in Lakewood. We've been around since 2012. I lead our innovation group. And today I'm going to be talking about making large language models more reliable through tool usage. So I assume everybody here knows that large language models are not reliable. This is a great article from May of last year at this point. What they do is they generate plausible sounding answers. They don't generate answers. They don't tell the truth. They don't lie. The reason is because they don't actually know the truth. Therefore, they can't lie. Right? Go read this article. I'm not going to talk more about why they're not reliable. Brady Booch, who likes to talk smack on Twitter, likes to call them an unreliable narrator. I do enjoy unreliable narrator movies like Memento and Fight Club. So I thought it was a good opportunity to put that slide up. There are 4 types of unreliable narrators. I didn't know this. If you look at the Wikipedia page, there's 4: the Picaro, the Clown, the Madman, the Naif. I asked, those are the descriptions of them. I asked, what does ChatGPT think of itself as being an unreliable narrator? And it decided that it was either a Naif or a Madman, depending on when I asked. And here are the reasons why. It doesn't have a general grounding. It doesn't understand the world around it. It's only got this text that it's been trained on and it's generating stuff. And it's a madman because it's hallucinating all the time. It'll make up stuff. Lawyers have used ChatGPT to submit legal briefs, and they'll just make stuff up, make up court cases that never existed. So Jan LeCun, who's another big talker on Twitter, he's a very prominent AI expert, leads Facebook's group. He has a warning to people looking at evaluations on academic papers, right? When they score really well, why is that? Is it because they put the data in the training set, or did they convince themselves through their prompting that they didn't teach the large language model the answer? And so that's a good warning, especially if you're writing a paper, you're trying to figure out these things reason. But I'm not trying to write a paper. I'm actually trying to create stuff that works. And so I see it as an opportunity, right? And the opportunity is you can test on the training set, and you can, put the answer in the prompt. And that's really most of the techniques that I use to actually get these things to do work. So what's the lesson of putting the testing on the training set? Well, put more stuff in the training set. And that means pre-training or fine-tuning. Right now, pre-training, so if you don't familiar with all these terms, pre-training is the idea of training a model from scratch. Right. So this is the thing that, they're spending millions and millions of dollars on. OpenAI is supposedly training GPT-5 right now. It's very expensive. And fine tuning is where you take a model that exists and you train it on a subset of data for some goal. And so one of the recent episodes that I saw, right? So Bloomberg GPT, this was a big announcement 6 or so months ago. They created their own 50 billion parameter model, which is not huge, but it's also not small. Probably cost them $1 million to make it, I guess. I don't know, maybe less, but it was, and they touted it as being very, world class at the time for a smaller model. Problem is, 6 months later, we got the 7B model, and these B's mean billions, like the number of parameters. So the small model, 7B is basically the smallest large language model that does anything useful. This is a case where the small model is defeating this supposedly larger model, just based on the iterations the open source community has done on cleaning up data, making it cleaner, other hacks and stuff that they've done to make these models more efficient and more accurate. So this is just really a warning. If you're going to do the pre-training thing, you're going to spend a lot of money and you might not get the results or the bang for the buck that you're looking for. The other idea of fine tuning is using it to inject knowledge into a large language model isn't the strategy I would go with, right? So this is a quote from knowledge graph person that was acquired by Google. The basic gist is you can try to machine learn a fact, but you'll never know if it actually gets it and remembers it. And you've also just spent a lot of money, where if you just put the fact in a database, you could just ask the database for that fact. So that's the pre-training and fine-tuning stuff. Then, okay, 5 minutes. So write the answer in the prompt. What's the lesson of that? So that is a technique called in-context learning. That's really the secret sauce, the whole magic unlock of these large language models, is that you can do what is called in-context learning, something that wasn't possible 3 years ago, or maybe 4 or 5 years ago. And what is in-context learning? That's just the techniques of prompt engineering, right? Chain of thought, tree of thought, and then few-shot learning. Few-shot learning is where you put a few examples in the large language model prompt, and then you ask it a question and it gives you an answer. That's few-shot learning. Retrieval augmented generation. This is the idea of retrieving some content, sticking it in your prompt, and then having the large language model do some evaluation or reasoning over that content that you retrieved. And tool usage, which is the topic of today. One quick commercial about retrieval augmented generation. I'm not talking about RAG today extensively, but everyone's excited about it. Great. I'm excited for you to be excited about it. First lesson, don't have unclean data. Make sure you figure out what your chunking strategy is. If you don't know what chunking means, figure out what chunking means. Don't have a misaligned embedding model. So some of these embedding models aren't very good at special purpose things. If you take a general embedding model and try to make biomedical text work with it, it probably won't work great. There's a query document mismatch. The embedding is like the semantic representation of a piece of text. The embedding of a question is not necessarily going to match the document embedding as well, because asking a question has a different shape to it and different semantics to it than documents. So make sure you know that. Metadata filtering is key. It's actually pretty easy to do. You should do that too. Similarity does not equal relevance. Google these terms: re-ranking, Colbert, and DSPY. Those are, I think, going to be the things that people are very excited about in 2024. And then read this book, because it's, you know, an oldie but goodie, and it still has good information for folks doing retrieval augmented generation. Okay. This was a talk from OpenAI during their dev day. This kind of like the off hours dev day, not the Sam Altman thing. This chart basically tells you just doing naive RAG, right? The cosine similarity thing, vector similarity search, is okay, but obviously not that good, right? 45% accurate. These are some of the tricks. Hide is that trick that tries to cover up that question document mismatch thing I talked about. Re-ranking, once again, a very good thing, meaning go to your database, get 100 best examples based on similarity, and then re-rank them using some smarter type of approach. And then the last thing is prompt engineering, right? Writing a better prompt, really thinking about it, and then tool use, which is what I'm going to talk about. So lastly, what are my rules for 2024 with all these different techniques and stuff like that? Let the cloud providers do the pre-training. They're going to spend billions, or, you know, collectively on this problem. Leverage that. They're killing each other on price, so you might as well leverage them for the pennies per token that they're offering them at. Fine tune to save money. So once you've got a proven model and you're spending too much on your cloud provider, then you go ahead and fine tune, and then using context learning for everything else. Strong information retrieval and tool usage. Okay, tool usage. Finally, tool usage is basically this concept. You're hooking up a large language model and you're telling it you have tools. A large language model cannot call tools, right? It can't actually do anything. All it can do is generate text. But it can generate text that looks like a function call, that looks like, you know, basically has like a little, you know, token, a special token or a special marker in it to say, hey, go call this function that you told me about. So the basic gist is you have a set of functions, you give that documentation to your large language model, tell it that it can call them, and then it'll tell you when to call them, and then you go ahead and do that. So getting the weather is kind of like the canonical example. You know, if a person's asking a large language model what the weather is in Chicago, well, they don't really understand how large language models work. You know, one, it's not up to date. Two, it doesn't have access to the weather, but it can realize, oh, yeah, I can go call this function that I have available, which is the get weather function, and then I can get that answer, and then I can put that answer in my response. So that's what I mean by tool usage. Hopefully that makes sense. Okay, so I'm going to start with code, and then I'll back into like kind of like what the code meant. So I apologize. So let's get back to the unreliable narrator, right? I was, you know, doing my Wikipedia, you know, ADHD thing where I was reading about the different types of unreliable narrators, and I said, oh, that's actually good categories. Let's go ahead and build a demo from that. And so here are those 4 unreliable narrators. I put them in an enum. And then I said, oh, let's go ahead and go do movies and find some. So, just to kind of make more concrete what the different types are. Fight Club, great unreliable narrator. I don't know about Willy Wonka being that, American Psycho, and Forrest Gump. So I'm going to take that enum and we're going to write some code. So the enum is going to be put into what's called a pydantic class. So the class is basically an object in Python. Think of it as a Java object or whatever programming language you like. But this is a library in Python called pydantic. And I'm going to define this character to have a few attributes. The first one is a movie name, then the character name, and then a field that's basically a flag, a Boolean that says, is this an unreliable narrator? And if it's true, I want then there be a reason. And then I want you to tell me what the type is, and that type goes to this enum. So I'm declaratively describing what I want the large language model to think about when it's responding to me. Okay. And I'm doing some very specific things here in this code, which I think is relatively easy to understand. I think if you weren't a coder, you could still kind of get what's going on at a high level. And so I have movie name, and then I got some examples. That's actually useful. That's actually sent to the large language model. The large language model can go, oh, I think I knew what he meant by movie name when he sent me this, but now I really know. I know that Forrest Gump's a movie. And then character name, same thing. And maybe it'll even connect the fact that I did these three things, right? Like I connected Forrest Gump to the same movie name and Tyler Durden to Fight Club. And then I have a Boolean. I didn't put a description here because I thought the name was pretty good and I was running low on time. And then reason, here's an example of that prompt engineering thing I glossed over earlier, the chain of thought. Chain of thought is when you ask a large language model to explain itself, it actually does a better job at answering. If you ask a large language model, hey, give me the answer to this question and just give me the answer, and it says yes or no, it's going to do way worse than if you say, I have a problem, here's what I'm trying to solve, please explain your thought process, and then give me the answer. It's going to do a way better job. That is called chain of thought processing. There's papers about prompting, there's papers about it. So I'm doing a chain of thought here where I actually explain it. Hey, tell me about why this person's an unreliable narrator, and then, and then tell me which type they are. And then at the end, I then ask for the type. Okay, even with all that help that I gave it and ran it, and here's how you run it, right? So basically, you got to have an OpenAI API key. I'm using this library called Instructor, which I'll talk more about. Hook it up to a model. I think I actually did with 3.5 Turbo. And then I say, okay, go ahead and give me a list of characters. And then I give it a top level prompt where I say, generate 5 random characters and then tell me what type they are. And then print it out. So I run it and it fails. And the reason why it fails is basically it's like making up new types, like it's insane narrator and imposter narrator and stuff like that. And it catches the error and then it says retry. So this library Instructor actually figures out that it's got the wrong answer, and the validation of this library pydantic caused it to fail and then catch itself and then keep running. So then it does the next pass, and the next pass it figures it all out. And then it figures out, 5 random ones, and it gives me the unreliable narrator type, and then the text in italics is the reasoning. So this is showing a few different techniques: chain of thought, validation, and then allowing the actual application code, which is deterministic, right? Our code that we write is going to run in the same way, unless some whatever energy spark from the sun causes our computer stack wacky. But for the most part, they're going to run the way that we programmed them. Large language models don't do that. They're probabilistic. They kind of give you different answers based on the number of times you ask them. So I'm using a library called Instructor. There's a few libraries out there. This Instructor one has been ported to JavaScript. This talk, Pydantic is all you need, is really good. It's up on YouTube. It was at a conference, the AI Engineer conference I went to. The example I showed earlier was structured generation. He gives an example that's information extraction. So rather than just making stuff up whole cloth, you can say, oh, here's a sentence, find a detail. In this case, it finds a user. I use these types of techniques with smaller models that we fine tune to do information extraction on medical information all the time. So check that out. It's using a library called Pydantic. Pydantic, like I said, just allows you to do type annotations on your objects, which allows it to be communicated to the large language model for what are called functions. Pydantic does this type hinting stuff, data validation stuff, as you saw. It failed with the enum. And then it has this capability called model JSON schema, which is generating an open API schema. Open API is this web standard for describing APIs, their endpoints, and the data that they accept. This is an example of the Swagger pet store is the classic example of pets. And this is kind of like what a schema looks like, the different parameters, the name, whether it's required, what the data type is. Here's an example of that get weather. So the get weather example is up on the OpenAPI website or OpenAI website. And so in this case, it's just expecting one parameter, the string, which is the location. Oh, sorry, location and unit. So unit is the other argument, whether it's expecting Celsius or Fahrenheit. And then, so that's how you work with functions. So we have these things, we're talking to an API, we're providing it functions, and we're getting back calls. And that call allows us to get nested, validatable JSON back that we can then parse and then use in our application. And so that's the application calling the LLM. This is an example of where the LLM calls my application. So I've been working on a custom, what are called custom GPT. And the basic gist of a custom GPT is you give it a logo, you give it a name, and then other people, you can share it with people. And then people can access your GPT and do stuff with it. Most of it's kind of boring. Most of them are kind of terrible, actually. But there is one capability, which is the actions that differentiates your GPT. The action means it actually calls your API. And it calls your API and you describe your API using your OpenAPI schema. It can do authentication and it works pretty well if you configure it correctly. And so to define your schema, you build an app. I built this app in Fast API and deployed it. And then you can, basically it tells it what the parameters are and how to call it. And these are what actions look like. So when you're configuring the GPT, you can basically just import from your URL. And then when you talk to the GPT, it comes back with the information and then uses that information in the chat itself. So you can see here that it actually calls my API, provides the name and version of this package that was part of this little GPT that I made. And you can see the code. So PyPI GPT is the project that I have up on GitHub. It's a basic Fast API project. And you can see it. And I also have screenshots of walk you through exactly how to set up your GPT and have it work. I have a website. I have, it's my personal blog. I have Twitter, LinkedIn, and an email address. If you have any questions, feel free to reach out to me. Happy to talk more. And I'm down to 2 minutes and 44 seconds. Any questions? No? All right. Oh, yes. How do you validate GPTs? How do you validate what? Mm-hmm. Yeah. So that's a good question. So the main challenge with this stuff, right, is the accuracy, and it all comes down to what are called evals. So an eval is basically, here's my test set that I'm not going to give to the developers to use to actually either train the application or develop the application. So evals is a critical part of what we're trying to do. As of right now, as of today, GPT-4 is the best model. GPT-4 hooked up to actions is the best way to get up-to-date information, limit hallucinations, limit a lot of things. It is still not perfect. It is still going to it's still going to make stuff up. Right now, the way I treat them is I treat them as an assistant. The goal is we're building assistants that subject matter experts can use to do their job more efficiently and effectively. And that's it. Everything else that people are trying to do is not a good idea in 2024 Q1. Does that make sense? Test sets are critical if you're building a model, training a model. So the way we do information extraction, for instance, which is what our company actually deploys in production right now. Information extraction, we have quality metrics that we're continuously measuring against, and we have curators actually review work and correct things and save it. And then we monitor how correct that information extraction is over time. And we're also monitoring how fast that curation team is getting their jobs done, right? So in a good scenario where we're doing what's called NLP and OCR on medical documents, in a good scenario, the OCR and NLP is right 98% of the time. 2% of the time, that means it's not right, right? So that's why we have that human in the loop that are making corrections. Yeah, so I see RAG as a subset of tool usage, right? So in ChatGPT, for instance, when you're actually in a GPT and it calls a web browser, it's basically doing a Bing search and bringing content back and putting it in there. That's basically that's an action of one thing. Last slide. So yes, I see it as basically a subset of that. And does that help? Sorry if I didn't answer your question.
Sorry, we got it. Sorry.
Oh, next one. New rules. We're done.
Brands. That's it.
Myself. There we go. And we just had a talk right before this. One thing that I've noticed when it comes to models that are hosted, for example, ChatGPT, about 6 to 9 months ago, I was able to ask ChatGPT to generate all kinds of code for me. Last night, I had an issue getting a video backup of one of the demos, and I wanted to download it from YouTube. It basically said, I can't do that. When I inquired why, it's because of copyright and everything else like that. When I said, well, why don't you continue? This is actually a video that we've uploaded. I just don't have access to it right now. And I don't know if my colleague will be able to share with me in the morning. It still said no. I went to Stack Overflow. 2 minutes later, I got the code. I double checked what Copilot can do. Copilot, by the way, has the same model GPT-4 and it's free. So you don't have to pay $20 a month for the features. It also generated the code. So one of the differences I've seen over the past year or so is some of these models have changed how they behave. That's part of the alignment that happens with likes of OpenAI, Anthropic, and so forth. And that's one thing to consider when it comes to models and how you use them. The other thing that we've noticed is that open models are quickly approaching the capabilities of the closed source models. And I'll have a slide on that. The other thing, of course, is to consider what happens to companies such as OpenAI. We've all heard of the drama that took place with the board late last year, and things could change rapidly, how these companies behave, how the models are supported, who are the core engineers that will support and build these latest and greatest models. So things change rapidly and need to be ready to be able to use other models as necessary. So the next opportunity that's actually from September, coming from Gartner, is the Enabling Enterprise Gen AI. And why is that? Some of the key things to notice and observe is that there's a huge opportunity. The thing about generative AI is it's great across horizontal use cases. And then you can go into each vertical. So document summarization, Q&A, and so forth. And there's a huge opportunity in that, as you can see in this slide. There's going to be also a lot of money going into that. In about 4 years or so, we're going to see about 8x increase, over $150 billion into this space. So it's growing rapidly. So one thing that I wanted to ground with real quick is earlier last year, we had a customer, OCBC Bank from APAC. They've got 3 real cool use cases, Wingman, Whisper, and Document AI. Wingman is used for auto completion, code blocks troubleshooting, and code explanation, while Whisper simplifies all kinds of contact center processes, identifying, solving customer complaints, and so forth. And Document AI is great for summarization, QA, and translation. What this means is that these use cases ground these numbers more specifically. The previous numbers were from a McKinsey report late in June. These are specific numbers and benefits that a customer has observed. So 20% productivity gain combined with 80% savings versus using GitHub Copilot. That is a huge advantage. And the other numbers, of course, if you translate them, equal to millions of dollars in savings by using those models. They actually use use closed source models to prototype a lot of things, and then they bring the open source models back on-prem and run those 24/7. That's how they optimize a lot of things on cost. So one thing I want to address real quick, what are some of the challenges that we see in enterprise AI, specifically enterprise Gen AI? And afterwards, I'll be curious to hear what you've observed, what kind of challenges you're facing. This comes from some of our customers, as well as some of the analysts I've spoken this year and last year as well. One is data integration. How do you actually streamline data access? So you feed your models with all the latest, greatest data. For example, the RAG architecture that Ian just mentioned, you've got to be able to feed that data, and hopefully you got fresh data so the models know what's the latest and greatest. The other thing, rigid model infrastructure, having modularity, flexibility, and of course, AI operations. When it comes to large language models, LLM ops specifically, one thing to remember, flexibility was actually the #1 thing that OCBC Bank mentioned last year. That is important because you want to be able to swap in the models that are smaller, faster, cheaper, and better, of course, when they become available. One thing that they did really well was to get the executive team sign on and being able to swap these models with very little signatures from the very top. So they can literally change the models when they become available every week or 2 weeks. And that is one very important thing to remember when it comes to having successful model deployment that is actually competitive in the marketplace. And of course, last but not least, in the enterprise AI, and frankly, for everybody, that should be a very important thing, security and governance. These are core elements, but it's not just the AI models and the AI apps that come with it. It's actually having this across the entire stack, from when you ingest the model all the way to when you ingest the data, all the way to when you deploy the model. So we've identified 3 key pillars that should pretty much resonate with everybody. One is you've got to have data and access to all that data that provides you enterprise context. 2, being able to deploy any model, closed or open source. And 3, having the security, governance, and lineage across your entire stack. So when it comes to data, one way to look at it is, do you have actually access to all of the data, to all of the data that you have combined? Do you have a catalog so it can come and be used in your models? Models here can be swappable, but that provides you all of the insights. Another way to look at it is if you just use the model without having that context, you might have contextually inaccurate responses or hallucinations if the model tries to replace you with something that it actually doesn't have data to back it up. So having the data context, having the enterprise context is significant and important when you want to have these contextually accurate responses, non-hallucinated responses. Any model. The other piece is having access to any model you want. If you want a prototype, if you want to have good results real quick, having access to proprietary models, closed source models is very important, but then you might have compliance, privacy, and all kinds of security issues. You don't control those versus the open source models that are catching up to the closed source models. They are rapidly improving, but what you do have, you have complete control over those models, and that is one very important piece. So one way to look at it, how good the open models are becoming, the purple line is actually the closed source models. That's from October of last year. The orange line are the open source models and performance. And this specific is the 5-shot MMLU performance. Tasks about 57 different tasks that it does, from math, science, law, and all kinds of questions, answers, comparing to how humans perform. And as you can see, those lines are basically intersecting, or will intersect very, very soon if that pace is being kept up. The thing to remember, when you actually fine-tune what Ian said previously, when you fine-tune those models on these very specific use cases, those models can actually outperform those closed source models. So a much smaller model that's cheaper, faster, can become more accurate and better in those responses versus these much larger models. So that could actually translate to cost savings as well. The final piece, of course, is the security, governance, and lineage. Security, governance, and lineage across the entire stack. So again, when you ingest the data all the way to when you deploy these models, so you can have that trusted AI with all that trusted data as the backend. So for our case, if with Cloudera, we specifically build the pieces on the very top. On the bottom, you have access to any kind of infrastructure. We can run on all kinds of clouds, AWS, Azure, GCP, but also have access to specialized hardware, such as, for example, the latest and greatest NVIDIA cards, such as H100s. What that provides you is that accelerated processing, not only in fine-tuning models, but of course, deploying and doing inference on those models as well. The other pieces that are at the top of our Open Data Lakehouse is being able to access both the open source models as well as the closed source models. So giving you that flexibility, again, going to one of those pillars, any model, deploy it and use it however you want. Of course, having access to model hubs, additional models, for example, from Hugging Face, as well as their additional data sets, so we can fine tune those models and their applications is quite significant. The other piece, of course, is being able to use any kind of vector store that you want to have. We have 2 vector stores you can use. That could be open vector stores, for example, a Milvus vector store that provides you that RAG architecture, so you can provide context to your models. But also, perhaps you don't want to deal with that and you want to use a managed vector store such as Pinecone. That is another way to do about it. And of course, the one very important thing at the top is how quickly and how well you can deploy these AI models at the very top. So having that entire stack that enables you to do so end-to-end and being secure is quite important. The one thing that I want to mention is at Cloudera, we have this entire stack. So one thing to remember when you're actually looking at the AI models is ask yourself, how are you going to bring the data? How are you going to do all the data engineering pieces? And where are you going to store it? How are you going to store it? And then how are you going to deploy these machine learning models to have that trusted AI for this entire stack, which is actually very important to enterprise AI. So now I'll transition to what was originally scheduled for this session is actually the examples of our applied machine learning prototypes. So these are these end-to-end solutions or quick starts that you can deploy literally within 10 or so minutes. And I've pre-deployed some of them that I'll show you in a moment. And they're very useful for if you want to get executive sponsorship, executive buy-in, for example, in deploying some of these AI models. So for LM specifically, we have some of these latest ones. On one hand, you'll have the third-party hosted models. Those are, for example, the ones from OpenAI. Perhaps you're using their API to get access to the models. They're great for prototyping, getting some insights. Perhaps Amazon Bedrock, you need to access their closed source Anthropic models. And on the other hand, maybe you wanted to transition to open source models. For example, for Q&A, for fine-tuned models examples, or perhaps you want to combine real-time ingestion with using something like a managed vector store, and then maybe Llama to the latest and greatest open source model that we have today. So what that shows you is that we have these pre-built applications that you can rapidly deploy, and that is a very, very important thing for a lot of the enterprises. How can I quickly get this in? How can I put my data set in and then have this AI model perform and showcase these different use cases? So this is actually a slide also from OpenDay Dev Day, modified to map some of these applied machine learning prototypes. The key techniques, one, of course, is prompt engineering. How do you modify? How do you ask better questions? RAG is what Ian mentioned before, is retrieval augmented generation, is how do you bring that data to your model to give that additional context? And of course, the fine-tuning, being able to specialize these models, to adapt those models to these unique use cases. So I'll cover 2 of these today, the RAG and fine-tuning, but these are probably some of the most popular use cases right now to get those models up and going. Another way to look at it is how much experience you need to get them deployed. Of course, prompt engineering is the easiest and simplest one to get started. RAG is somewhere in the middle. It requires a little bit more experience, but you don't need to be a data scientist to actually get this deployed. You can have some data engineering experience or just generally developer experience to get this going. And of course, fine-tuning, or in this case, parameter efficient fine-tuning or PAS, is a way to get these adapters to basically do some more specialized use cases. Of course, the full blown is the full fine tuning, but that is generally much more costly. So these are the top 3 use cases that you can get started today quite easily. And there's some benefits that you can see over here. So the demo one, I'll go over the chatbot, the augmented enterprise data piece. And basically, this is a way to look at it. If you just bring the model that's been trained on all of the internet data, you may get those hallucinated responses if you ask the model itself. Now, if you have a vector database, then that vector database can, based on your search query, pull in the knowledge from a knowledge base, put it into the actual context prompt, and then give you a factual response, non-hallucinating response that is much more contextually accurate. So let me go real quick, show you that AMP in action. So right here, we have the full interface of Cloudera. So as you can see, this is the entire stack. So how you ingest data, so data flow for real-time streaming data, engineering, warehousing, operational database, and machine learning. So we'll jump into machine learning. And let me make sure I can go full screen as soon as I move this Zoom thing all around. And one thing you'll notice right here is we have this basically folder of these different applied machine learning prototypes. So again, these are these different examples from structural time series to, churn prediction, all of that. And of course, the latest and greatest, the large language model, specific applied machine learning prototypes that can get you started quickly. So the one we're going to look at today is the, actually one of those is the LM chatbot. So let me quickly jump into this one. I already have it deployed. Hopefully it still works. Let me see what's going on right now over here. And it's refreshing. Okay, so basically before I deploy it, the whole setting for this model is right over here. Quick description of what this model does. A lot of these components actually are from Hugging Face, but going into the Gradio here, what I want to do is ask it what is CML and show you the comparison between the two different answers. So CML is cloud machine learning. So let me ask this model, what is CML? And let's submit. Let's see what it does. This is right there, isn't it? Yeah. So what it's doing, there's going to be two answers. One is this answer over here. Okay, I'm still in meeting. Is that? Is it a meeting? Perfect. All right. Thank you, Doug. So the top answer, the one without the context, so basically the model's been trained but never seen any of our proprietary data, is that CML is a type of cancer, which is completely inaccurate. But for a model that has access to our data set, it says that CML, let me zoom in. I'll try to zoom in at least. Zoom in. There we go. CML is a three-tier architecture that consists of a presentation layer, application layer, and so forth. Basically, a description of what CML is all about, which is what we want. We want the model to actually be aware of all the data that we have. So this is basically an example, very quick example, simple one for what is what you can have with RAG architecture. So the other model that I promised you is this actual PEFT or fine-tuning model that I've deployed. And by the way, here's how you deploy these models. You just go click configure project, and then it starts the configuration, asks you how many GPUs you want, what kind of processing power you want, and all that. And I can say launch this project. Let's see, for example, I'm going to have 2 GPU workers from NVIDIA, etc. I may even have Spark. And so forth, and that model will be deployed. But I'm going to skip that because I already have it deployed. This is the fine-tuning portion. And so let me very quickly give you an example of what that is all about. So the fine-tuning, Ian also covered that. So you can have the full parameter fine-tuning, basically fine-tuning the entire model, all the pieces, much larger data set, and you essentially get a new LLM. With PEFT, or parameter efficient fine-tuning, you basically just have a smaller, specialized data set that goes and creates these adapters. So now you can have 3 types of different use cases. For example, natural language to SQL data set, detoxified data set, or instruction following data set. And then with these adapters, based on top of the base model, you can have these 3 different use cases which are very powerful. So this is essentially what we're going to do. So let's go into this model right here. We got 4 minutes left. Perfect. So those 3 examples that I've just mentioned, let's try and generate SQL. So essentially what I want is right here, from this prompt, create Jedi with a lightsaber color, give me a list of Jedi that have gold color lightsabers. So let's generate that prompt. And it's using all the compute on the back end. And what you'll see is that the base model response basically doesn't have any idea what the structure of this underlying database is like. The other one, the fine-tune with the PEFT, parameter efficient fine-tuning adapter responses, and select ID from Jedi wear lightsaber. Let me make sure this is larger right here so you see it all, is gold. So again, this fine-tune model now is aware of this, of what the actual structure is on the underlying database. The other one, say the detoxify statement. And over here you say, I had Obi-Wan, he always craps on me about the dark side of the Force. So let's say what this generates with a data set that should be used for detoxifying, again, building those adapters. So the base model responses, I'm not a fan of him either. He's just too much fun to be true. But the fine-tune response, which is not much better, is I don't like Obi-Wan. He always makes fun instead of he always craps on about me, the dark side of the Force. So again, very simple example of a fine-tune with the detoxified and all that. I'm going to skip the general instruction following, but essentially the idea is the same. So with that, you can basically go and if you want to try some of these amps, we have a 5-day trial. So you just go and sign up, and I can share a link afterwards as well. And you can get started and check these out. For example, the one with RAG that's pre-built with this entire infrastructure. And with that, I managed to do 18 minutes. All right, questions? Yes. Yeah, I mean, yeah, you can. Yeah, could we adapt the re-ranking as part of the process? Absolutely. I mean, now there'll be the next process that you do in the LLM apps, so building it out a little bit farther. But of course, the first piece would be just to start getting those responses, see how it behaves, getting the whole infrastructure with the amps. And then the next step would be, how do I add the additional pieces to rank it, and of course test it, and have the full cycle to get the models updated as it becomes better and improve it in that way. That was Milvus. 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 Yep. My question. Good. No worries. So the question is hallucination as a side of, I would call it actually hallucination as a side effect, or actually this is part of large language models. And the way to reduce the hallucination themselves to make the models more accurate is to provide the actual context with RAG architecture. And then the other techniques that Ian mentioned to make them much better. So all of the techniques combined that Ian actually mentioned would make those models much more accurate. Hallucinating less, there might be some additional alignment that you need to do. But the bottom line is that with this architecture, providing the context, providing the data necessary to those models, they should hallucinate a lot less and hopefully provide the actual answer that you're looking for. And if you use Copilot, you can actually say how precise you want to be with your answers and how creative you want those models to be. So if you want them too precise, it will actually just grab the actual data that you want and then give you the answer. So that at that point, there should be no hallucination at all. Contact information, I did not put that, but I can give you right of this. All right, thank you for that.
I think we're all set. All right, cool. All right, everybody, time for something a little bit different. I'm here to give you a talk about a recent project we did at the city of Cleveland. It's called Mapping Eternity, Geospatial Cemetery Management System. I'll give you a hint. I did use a little help from Copilot to develop that title, but it did a good job. So really quick, my name is Joe Sohrabian. I'm a spatial analyst for City of Cleveland. Do a lot of other stuff too. I think I've slowly realized that spatial analysis, working with spatial data, it's really just one piece of the pie of the bigger data world, and I more and more see it less as its own unique thing. With that said, I do a lot of work with Esri's software, the guys who bought us our pizza. They're the biggest GIS software company, at least in North America and a lot of the world. So I do work a lot in their tools, and it's in their proprietary system. A lot of people see it every day, all the time. I'm in there a lot. I'm also using some open source stuff as well. So the department we're in at the city is relatively new. Just to give you a primer, it's the Office of Urban Analytics and Innovation. We're basically the data hub. We're the center of excellence for the city. By that, we mean we try to reach out and improve decision-making, get data-driven processes, new innovation and new technology into city departments. A big piece of this was working with the Public Works department for the city of Cleveland. So I guess another thing I'm stressing, I'm not an archivist, I'm not a historian. What you're about to see, this was rolled out for operational need and tangible improvements for the way the city operates. So before we get into it, the city of Cleveland has 12 cemeteries. Most of them are inactive by now. They're pretty old. They go back to pre-Civil War, early 1800s. I'm sure even older, as long as people have lived in Cleveland. But these are the ones that are owned by the city. So this doesn't include Lakeview and some Catholic cemeteries that you may be familiar with. The newer ones here that started burying people in the 90s are more active. And there's 500,000 plus people. The bulk of those people are in Highland Park. If you've been out in Highland Hills, it's a huge plot of land that's actually owned by the city outside of city limits, next to the golf course that towers over all the other ones. Highland Park and West Park combined by area are 64%. So they're pretty big, and they're the administrative offices of the east and west side of the city cemetery system. So getting into the records that they have for cemeteries, we have interment data. That's where people are buried, 500,000 of them to be precise. And that's in two buckets. That's 1980 to present, which is held in these annual SharePoint lists. This is a couple generations old of SharePoint, if you're noticing some of the icons and stuff. And then everything before 1980 is hosted by some third-party volunteer groups. The Eastern Cuyahoga Genealogical Society digitized and scanned some stuff. I'll talk more about that. Other than that, it's not data yet, but the only records we have here are location data in the form of maps. So we got archive, section maps, cemetery maps, lot maps, and I'll show you how we made this into a project. So the SharePoint data, they only had 72,000 people from 1980 to present. Most of them were in the newer cemeteries. It's mostly, people's name, their birth date, their age, some other stuff that I left out here. The stuff you would expect when we're tracking people being interred. This stuff required a lot of deep cleaning. I'll talk more about why and how we dealt with those issues. This tells you where people are down to the grave. Here's that third-party source. It's about 350,000 records going all the way back to the 1800s. This is the website that you could access it on. It's called OHGen Web. If any of you have do this as a hobby, you're probably familiar with it. We ingested this straight out of the web with the help of our data engineer. We pulled it off and did a lot of standardizing and wrangling of this. Each one of these records, so these are the people there, comes with a link that takes you to a scan of literally where that person was cataloged. So this is one of those scans, 1864. This was printed out with a typewriter probably in the 40s, and these people scanned every single page in every single book that was on record in the early 2000s. So the key piece of information, this is a geospatial project. These 4 columns here tell you the section, the lot, the tier, and the grave number. I'll tell you what that is exactly, but that's important. It's in the scans. Unfortunately, whoever volunteered to do this, the way they structured this, they didn't type it all those things in. They only typed the cemetery itself. So digitally, we only have a record of what, in terms of a machine readable table, we only have location down to the cemetery, not to the actual section. That's important for later. So some of the location info, moving on to that. Here is us going to the basement of the Highland Park office and finding lots of maps in buckets that were water damaged and recently put into tubs. Digitally, there is no spatial info. We're starting from scratch here. We have paper. There's ways around that. And there's a key person in the audience, and I'm glad he's here. That was part of that as well. This is a location plan for a cemetery, so we need all this stuff to make a geospatial layer. This is us being like, what the heck do we do with all this? The second we saw this, we're like, what are we about to get into? There's hundreds and hundreds of maps. Why we did the project really quick, there's a few internal and external reasons. Internally, you can't look people up very well right now, and you have to rely on third-party sources. That's not good for a city operation. Managers can't really do work orders when everything is paper and index cards. Burial records are not standardized. I'll talk a little bit more about that. And then the locations themselves aren't standardized, which is kind of concerning if you're talking about where people are buried for the rest of their lives. You kind of want to have an easy way to say how. Externally, there's literally no self-service of this information to the public. So it's a call line. If you go stand in the office every 5 minutes, every 10 minutes, they're getting calls of people looking for loved ones, and people got to staff those phones. In 2024, that is not something we want. More to that end, oh, I forgot to turn this on. You got me right, Tom. This is a huge missed opportunity. You know, people expect in this day and age to be able to find their modern government records online, at least some search tools, some self-service options. So we thought this was a huge opportunity to help like that. People also don't have detailed maps. You have to show up and there'll be a placard that tells you what section. If you can't find somebody, you got to go to the office. They'll tell you to go down 3 rows, turn left, and then go to the tree and turn right. So not a good situation for the public either. And there's a lot of volunteers that want to do this. If you're not familiar, there's a huge community for this. So the combination of these two factors, that all these burials are individual SharePoint lists and the staff can only search one SharePoint list at any given point, results in a really clever but unfortunate workaround for the staff, which is if you don't know when your great-great-great-grandma was buried exactly, the first thing they do when you walk through the door is they ask you who was president at the time that they died, which is a sign that the tool is not built for your needs. But it is creative, you have to admit. You get down to 4 years, and if you know your American history, you could start looking for them. And if they're not in the digital record, so that's anything before 1980, they're going to be pulling you out of one of these books and looking it up one by one, going to your name. And that's a person's job. That is a tool that is not doing too much work for the staff. Some more of the technical benefits, the data integrity, first and foremost, I think. So there's 12 cemeteries. There should be 12 unique values for the cemetery field. There are 133. That's a problem. Somebody didn't have coffee. They misspelled one of the cemeteries. That was in there. These SharePoint lists are from like 2005, decades of typos. You get something like that. Another benefit, obviously, interactive access. When everything is in a SharePoint list on an internal network, it's hard to share that information with the public. And this is the kind of information that should be shared because it's living history. A little background on how people are located. It's a tiered system. So there's a cemetery, there's a section, and then there's a lot or a tier. A tier, we learned, there's some weird lingo in this world. A tier is a la carte version. If your family doesn't buy a full lot, you can get a tier and you can get a single grave in it, and then finally the grave. So the way we approached it when we started the project, we knew instantly that we're not going to map 350,000 graves. It's not even that useful right now. So what's useful? We cut out the grave portion, and then we combine lot and tier because those function as one functional unit. Those don't need to be separate fields. That is one piece of the hierarchy. So we began digitizing all those maps to start because we needed a spatial asset. The cycle for that was the way it looks here. First, you got to scan some maps. Then you have to process those images to be ready. You have to georeference them, which I'll explain briefly if you're not familiar. And then you got to trace over them with a mouse. I see Ted's eyes, like the sound of silence is playing in his head right now. It's because Ted was a big piece of doing this tracing and digitization. Then you got to number the lots and do quality control, and then you got to start the whole thing again for the next cemetery. Here is how digitizing works. So the Cleveland Public Library, if you're not aware, has a huge large format scanner there that my volume is off good because it's loud. It's the sound of a vacuum, and it sucks the whole paper down flush as it scans over it at a pretty high resolution. So once you get those images out, you have to tell a GIS system where it lives, where it is on planet Earth. You need to match those points on the image to a place in the world, and the software a lot of different spatial packages will be able to reference that raster information to a spatial location. So here's how that looks in steps. You have an aerial image, you have a scan, you tell it that there's these 3 points that have stayed the same since 1912, and it knows to transform that image and place it in the right coordinates. So once you've georeferenced it, oh, here's an example. Sometimes we didn't have the full cemetery map. We had a section map, so they ended up being this giant layer cake of sections like this, which was kind of a cool effect. This is, after you draw them, you got to number them. There's some tools that accelerate that. I think because time is of the essence, I'm going to kind of skip through some of the details. And then the interment records needed some work too, right? So we didn't just want to draw people's the shapes of all these sections. We needed to prepare all the interment records. So there's about 430,000 people that were standardized and cleaned and scraped off the internet and out of the SharePoint list into one unified location going all the way back. That also required cleaning. The cycle for that was try to join those records, their location, to the spatial asset that we created, and they're going to fail. So why did that fail? What's the logic that caused it to fail? Update the records, update those location fields, and then try joining it again, and going until we get a decent result where most people are actually joined to the lot that they belong in. So a typical cycle was 500 people are not being found. They're all in this section in Highland Park called 18R. And after checking with the cemetery supervisor, we learned that there is no 18R. Technically, 18R is the Russian section. Formally, in terms of the data structure, there shouldn't be an 18R. That's just the shorthand that people have been using. So we need to modify the logic in here. We use some APIs and some notebooks to do all this iteratively so you can see it live. We say, okay, when you see Highland Park 18R, just make it 18. Forget the R part. So there's a lot of custom one-time logic that's built in because these systems are complicated and not predictable. Finally, update and join again. And hopefully you got a better result. So that was the data project. I think the really cool part of this was the applications we built for the staff to use and then for the public to use soon. It's not public yet. You're going to get a bit of a preview. Doug, how am I doing on time? You go. I got to the end. A quick overview of how we deploy this. We used some WebGIS tools. Like I said, the city of Cleveland works is an Esri shop. We have the full license. WebGIS, basically you publish these services. There's server endpoints that can deliver that info to apps and maps. Also tables, which is a key part of this. It doesn't have to be spatial. It just happens to be what this company does. And then we build the apps with some drag and drop builders. So not a lot of custom developing. We're not front end people here. We try to make the most of this stuff. One thing that we could do was add a lot of powerful customization to the apps, and I'm going to share some of that. I'm looking forward to share that with this crowd because a lot of other audiences, it's a little too intense for them. The main thing they have is it's like a subset of JavaScript that they call ArcGIS Arcade. It's like a JavaScript Python mix that is all throughout their ecosystem. So if you know just a little bit of it, you could really supercharge some of the apps with it. Here's an overview of the service we created. It's a bit of a diagram of the different components. We have a cemetery layer that's spatial, a sections layer that's spatial, the lots and tiers that's spatial. It has a location ID and that joins to people's burials by that location ID. People could also have photos and documents attached to them as blob, and it gets related to those people. So that's great for cemetery records because somebody could post, a portrait of a loved one, and that'll stay in there and be accessible. Really quick, what the feature service is, this is a diagram from Esri. It's technically an instance of ArcGIS server, and it's an endpoint on that server. Esri will set it up for you and maintain it for you and never force you to touch any of the back end of it, and they call it a hosted service, and they charge a pretty penny for it. We have many of those pretty pennies because we have an enterprise license for it, and it has a RESTful API. So we're not really touching the API directly. There's a Python API for the API that we use quite a bit, and ArcGIS Online is the interface for all this stuff. There is an open source version of all this, that all of this stuff is, there's a deep connection between the two where they copy each other. So there is one that's called the web feature service as well. The structure of how we shared this out, we had an internal bubble for management and internal work on the right-hand side there. And then on the left-hand side, it's a mirroring of that same exact service with a few modifications, and that feeds the public applications. So you get internal applications and public applications. You could filter things out just inherently. Nothing makes it to the public that includes like the phone number of the next of kin information, the sister or brother or whatever. That's not information that ever needs to make it to the public. So you could choose what columns you mask out, whether it's 48-hour lag or 3-day lag or 4-day lag. You could configure all that and it goes and pipes out to a totally different environment, but they always stay in sync and you never have to do anything to make them stay in sync. So we got those two major applications to start. They officially adopted the manager application and they're using it now. Thank God. They're not asking people who the president was when they walk in, which is a huge lift for them. And then we have the viewer that's hopefully launching in spring 2024. They both use this experience builder, and I'm going to show you some of the highlights of what you can do with this. You have an app canvas in the middle. You have widgets on the left, you have properties of the widgets on the right. There's many onion layers of stuff you could do with this, but some of the cool highlights and features, you could develop some forms, smart forms that prevent those kinds of data integrity issues that plague this whole thing. So this is a cemetery record. This is planned for decades and decades, not a 5-year cycle. So as many of these guardrails as we can put on it, the better. So in this case, you could configure what fields are required by your data entry staff and whether there's any of them that are custom calculated on the fly. So what you're seeing here is somebody puts in a cemetery in there for a new burial, and it'll automatically generate the next sequence of the interment number based off of that record. I think this is way too small, and I think we're already at 19 minutes, so I'm gonna skip through some of this. But this is that ArcGIS arcade code that does that. It has the environment variables of what's going on in the app at any given moment. So this is, on a high level, this is saying, okay, they put in Highland Park Cemetery. I'm gonna look for all the burials in Highland Park. I'm gonna look at the max of the interment number, and I'm gonna return the max plus 1. Bam, you got your next interment number. Nobody has to manually do that. You could also do that same form, calculated expressions with drawing. So there's some functions that say, okay, if what this person just drew intersects with this cemetery, then obviously what they drew belongs to that cemetery. So populate that field with it. And that's what these 10 lines of code do. It says that there's a cemetery layer, there's a current drawing. If the current drawing intersects with the cemetery layer, return that first cemetery, and that will be the ID of what that person drew. You could also do all kinds of cool stuff with that, with the pop-ups and things as people interact with the map. So if it's a historic record, in this case, it gives you an extra link to this like nice emoji. But if it's not, it doesn't show you that stuff. So that's all configurable with that arcade as well. And this is like the bread and butter of Experience Builder, that all these widgets are interactive. So you can say when somebody clicks on a cemetery on that list over there, automatically zoom in to the map all the way down to the cemetery level. So that's what that is on the right. It's saying when the selection changes, zoom all the way in for the user. And then here's just a few quick animation demos of how this works. This is somebody adding a new burial. You could jump to the cemetery. You could zoom into the lot that you want to add. You click on it, and then you add it as a related record to that lot. And this is the public version. So hopefully there's a lot of public interest in this. People could find their loved ones a lot easier. You type in their name, it'll give you suggestions. It's querying that service for this. And then as soon as it finds that person, when you click on them, it'll zoom in down to the lot that they're related to. So this person's related down to Alger section G39. 329. If you click on someone else that doesn't have it down to the lot, it'll show you the whole cemetery and it gives you a link to the scan. So a lot easier to find this information. And then finally, I know we're running over the future phases of this project. There's still 350,000 people that their location information just isn't a machine readable form still. It's just those scans. So we know that there's probably going to be some optical character recognition projects going on. Unfortunately, the scans that were taken in those 2000s are not the best. With some image processing, maybe they could be read with traditional character recognition, but we're not really, like I said, we're not historians, we're not archivists, we're city staff, and we're trying to get people to do more with their time and also serve the public. So we're not going to go do this first thing, but in the future, we're going to explore some processing of these images. And if the processing doesn't work, maybe some of these models could, at least the computer vision versions, of course, I know the difference, could help parse some of this through. And then to end on this note of all this hobby energy that I'm talking about, there's a lot of volunteers out there, a lot of seniors and non-seniors as well. On weekends, some people go out walking. It's a recreational space, and they help fill the historical record. You've probably heard of Find a Grave. Most of the cemeteries in Cleveland have a foundation because they're very historic. They go back to the 1800s. They want to give us information. They want to improve the records. They want to do all of the things. But until we did this project, there was nowhere for it to be received. So a big part of this is going to unlock these types of error reporting and volunteer projects. There's really cool stories that are dug out. Some Civil War barriers were found at the Woodland Cemetery Foundation. They have a huge database that they built themselves. Like, they should give the database to us, and we could actually consolidate it. Of course, they could contribute, and there could be a cycle and a connection with the community. There's another interesting find in Alger Cemetery of a former slave that got here from the Underground Railroad. They had no headstone. Someone did the research. Where does that research go? Until we did this project, and there's no permanent location. That summarizes what I said before. And then finally, there were a lot of people involved with this project, and will continue to be our public works staff. We're lucky. Change management has not been an issue. You show this to a lot of public employees that have been doing the same thing for 20 years. The first thing they're going to do is their eyes are going to roll back and they're going to say, that feels like a lot of work. That's a lot of change. Not from these guys. I'm on the phone with this guy every week. They're asking for this. They want it. It's a great a change from the typical. And then our team from Urban Analytics, our director, helped tee this up. Ted is right there in the crowd. He digitized 50,000 of those lots in 3 months. He absolutely ran through them. And then our data engineer and some other people in our office helped do this. That's last slide. I think I went over quite a bit, but if anybody has one question burning, I could answer. Yeah.
Is this a problem that you think a lot of other major cities have? Like, talk to other cities about this, and like any other cities?
Do other cities? One thing we've noticed is a lot of like private cemeteries have this problem, and they've solved it because they're also richer. So like Lakeview Cemetery has had, they have more of the resources. We're seeing more and more public sector doing this too, but not so much for like a whole system of 12 cemeteries. A lot of people, they'll do this for like 1 or 2. So this is slightly newer of a concept. Yeah, I think more and more they're realizing that it's time to move on.
Cool. Thanks, everybody. We've got some time to stick around and talk to folks. I just wanted to let folks go if they had, because this is the formal presentations are over. So thank you again for coming. Thanks to CSU for hosting us. Do you have a quick thing? And Sonny's got a quick message here.